Now, you got to chapter 3. And chapter 3 was the chapter that was about the graphs. Okay? And you learned basically that there was y equals a cosine or sine, b, x or theta. I'll use the letters in the book because the rest of the students probably had those letters. And back in Algebra 2, A was called a vertical stretch or compression. The minute you got to math analysis, we started calling it a vertical dilation. And by the time you got to chapter 3, we told you that was called the amplitude of the function. And the amplitude of the function, when you're graphing, helps you graph which variable? Y. It helps you with y because it helps you with that highest point and lowest point. Okay? And back in Algebra 2, that b value was called your horizontal stretch or compression. You got to math analysis, we called it a horizontal dilation. And some people think it's the period. That's the biggest confusion there is in this chapter, is that B is related to the period, but B is not the period of the graph. And the relationship goes like this. 2 pi or 360 divided by B will give you the period of the function. And conversely, 2 pi or 360 divided by the period will give you your value of B. And so do make sure you keep that straight. And so B, known before as the horizontal dilation, now tells you how you find the period of a function, or if you know the period, you use it to find B. But please don't ever think that if you know the period, that value is going into an equation. It never does. All right, now, of your 6 trig functions, cosine, sine, secant, and cosecant, so y equals, all of these, the parent function has a period of what? 360 or 2 pi. And it is only, which two? Y equals tangent and y equals cotangent that has half that period. Its period is 180 or pi. Okay? Then you got the letter D right here, and the letter D last year in Algebra 2 was the letter H. It was your horizontal translation, left or right. And when you got to this chapter, we called this the phase shift or the phase displacement. And it works the exact same way that H used to work last year. If it says theta minus 30, then it's 30 degrees right. But if it's theta plus 30, then it's 30 degrees left. Okay, so it works just like H worked last year in Algebra 2. And then you have your C. And last year in Algebra 2, this was your vertical translation up or down. And now in math analysis, it became the location of the sinusoidal axis. Whenever you tell us about the sinusoidal axis, since it's an equation, it's always y equals. So if we ask you what the sinusoidal axis is and you say it's 5, that's not right. It's y equals 5. We also basically showed you where the graphs of sine and cosine come from by basically doing what to the unit circle? Unraveling it. We unraveled the unit circle, and you got to see that your basic cosine function went like this. That's cosine. And your basic sine function went like this. What's the biggest thing to remember about these two? Cosine starts at its highest point and goes down. Sine starts on the sinusoidal axis and heads up. If something were to start at the lowest point instead of the highest point, you would say that it was a reflected cosine graph. It's a cosine graph where A is negative. If it were to start on the sinusoidal axis and start heading down, then it would be a reflected sine graph. Okay, any questions so far? We used the graph of cosine and sine to help us graph what? We used it to help us graph secant, y equals secant theta, and to help us graph y equals cosecant theta. By the way, what's the domain and range of both y equals cosine theta and y equals sine theta? The domain is all real numbers, and the range is y as an element from -1 to 1. And then we use the graph of cosine to graph secant. Anywhere cosine is 0, secant is undefined, and therefore there are asymptotes there. Wherever sine is 0, cosecant is undefined. So wherever sine is 0, then cosecant is undefined. And then the graphs of secant, basically where cosine is 1, secant is 1. And we see this parabola heading up. And wherever cosine is -1, secant is -1. And the parabola is heading down, and so forth. And the same thing for cosecant. Wherever sine is 1, cosecant's 1. And it's a parabola heading up, and a parabola heading down. So, what is the domain and range of y equals secant theta? What is the domain and range of y equals cosecant theta? What's the easier one? The range. Because the range for secant and cosecant is basically what isn't the range for sine and cosine, right? And so the range would be y is greater than or equal to 1, or y is less than or equal to -1. Same here. And then for the domain, it's all real numbers except x is not equal to. And for secant, x is not equal to the moments when cosine is 0. When is cosine 0? Cosine 90. So x is not equal to 90 degrees plus 180n. And over here for cosecant, x is not equal to 0 plus 180n. And technically, you could have just said 180n.